Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. Nur Ashke. So today my group mates and I will present about our group assignment, which is line following robot with the presence of obstacles. So the objective of this project is to ensure the robot follow the line provided in the track. Other than that, we also want to verify how to create and also design the mechanical structure of the robot using 3D circuit in Tinkercad. Other than that, we also figure out how to utilize the sensor, which is ultrasonic sensor for and photoresistor sensor to detect the obstacles and detect black and white lines respectively. Okay. Then lastly, we also studied concept of coding to run the programming in the Tinkercad simulation that will be discussed in this lab report. Okay, so the introduction of this project is the purpose of this project is to build an autonomous robot called line following robot. It is built based on specification. As for line following robot, Arduino Uno is the main controller, including ultrasonic sensor to detect the obstacles and photoresistor to detect white line and black line on the track. A closed loop control system is used in this robot. In order to design this robot, we have to consider a lot of things, which is the weight, the dimension. The dimension that we use is 16.4 cm times 10.7 cm. Okay. Then we move to the methodology. This is the track that given to us. So we have to do the robot following this path in this track. Okay, this is the table of condition. As we can see, if the distance between obstacle and line is 65 cm. So when it's more than 65 cm, the robot will move forward, which is the wheel of the robot left and right in the same value. If the distance is less than 65 cm, that it will turn left for this obstacle and turn right for the obstacle. But for this obstacle, there is special condition where the robot will stop for a while and then will turn to the right. Okay, so this is the circuit diagram which I already designed in Tinkercad. So we use Arduino board, ultrasonic sensor, and photoresistor. We use photoresistor than IR sensor because in this simulation, photoresistor can detect the white and black lines so that we can know our coding whether it is true or not. I think that's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. So my name is NORFAEZAH binti Jamil, and I would like to continue what my friend SYAABANI is saying just now. So this is about the mechanical structure of our robot, and this is the full view of the mechanical structure. This is the gear motor, this is the wheel, and we use 4 wheel altogether because it's more stable. And this is Arduino board, this is IR sensor, and this one is ultrasonic sensor. But like what SYAABANI is saying just now, for circuit diagram, we use photoresistor because there is limitation in Tinkercad, so we have to find another alternative to replace IR sensor itself. So as we know, IR sensor is used in our real life to detect black line. Okay, so this is the full view. Okay, this is the side view of our robot, and this one is the back view, and this is the battery, okay, for our robot. So this is the mechanical structure of our robot. Okay, next is for the flowchart program. So the flowchart is based on our track. So this is the start, and we declare IR left, IR right, and also the obstacle. And this is the input. Okay, then we meet the condition, and the condition says that if distance is less than or equal to 65 cm, if it is a true statement, it will meet another condition, which is if IR left equal to IR right. If it is a true statement, it will stop, then delay for 3 seconds, and then make a turn to the right. And if it is a false statement, it means that IR left is less than IR right. And then if this statement is true, it will make a turn to the left. And this one, if it is a false statement, so IR left is greater than IR right. And if it is true, it will turn right. Okay, so for this condition, if the distance is greater than 65, if it is a false statement, IR right equal to IR left. So if it is true, it will move forward. And if it false, meaning that IR left equal to smaller than IR right, and then it will make a turn to the left if it is a true statement. Okay, and if it is false, meaning that IR left is less than IR right, and if it is correct, it will turn to the right. And if it is false, it will delay for 3 seconds before come to an end. So the same goes to all of the output. So this one and all of this. At the end, it will come to a delay for 3 seconds before it come to the end. So that's all from me. I will pass to my friend. Thank you.
Hi, my name is ZAHRAA BINTI ZAKARIYA, and now I would like to explain about the result based on the track given. Okay, as you all can see in this circuit diagram, we use a photoresistor rather than IR sensor. It is because IR sensor in circuit diagram it cannot simulate the black and the white line. However, if using a photoresistor, it can simulate the black and the white line. Okay, as you all can see in this diagram, uh, photoresistor, this is photoresistor 1 and this is photoresistor 2. If photoresistor 1, resistor 1 detect the white line and the photoresistor 2 detect the black line and it will turn to left. However, when the photoresistor 1 detect the black line and the photoresistor 2 detect the white line, so it will turn to the right. Okay, but if both of the photoresistor detect the black line, it will move forward. Okay, based on the track given, there is a 4 condition that to make a robot to move. Okay, first condition is when the distance of the obstacle and the robot is more than 65 centimeter, then the robot will move forward. Okay, for the second, third, and fourth condition, when the robot and obstacle is less than 65 centimeter, then the robot will stop for 3 seconds, which is to make the robot to give a time the robot to turn to either right, left, or stop. However, in this case of the track, we decide to turn the robot to the right.
So, in the conclusion, from this project, we have successfully making a robot, and we also have verified on how to create and customize the mechanical design of the robot, and we also can differentiate the function and the difference between each of the sensor that we use in the track given.